We're going to work with algebraic expressions and then a few basic operations. And there's two things that we want to take care of in this section. The main one is we want to have you become familiar with common terms. Coefficient, term, factor, power, order, coefficient. All these things are things that I want you to be able to be familiar with. And then the other thing that we're going to do is we're going to add and subtract polynomials, which I think you'll find to be delightfully short and simple. So, a few terms. The first one, kind of a starting ground. Before we can talk about anything else, we have to define what an expression is. An expression is basically any group of mathematical stuff. Numbers, symbols, operation symbols, variables. Anytime you cluster a bunch of these things together, you end up with a mathematical expression. It's a very broad term. One example of an expression is shown right there. 4x squared minus 9 times the parentheses 5y plus 9.73 plus 8.5 ABC. That's an expression. I'm going to show you that there's really only one thing that can destroy an expression and make it not an expression. Think about that. We're going to come back to it in a couple of minutes here. But there's really only one thing that you can't see there that would destroy an expression and make it something else. The thing that destroys an expression is, I forgot I had that on there, equal sign. If you see an equal sign, bam, it's not an expression anymore. Then it's an equation. And we're going to come back to that later. But if you see an equal sign, not an expression. Then it gets promoted to equation. Okay, well, now, what makes up expressions? Expressions are made of terms. If you've got one or more terms, you have an expression. Terms are basically parts of an expression that are combined by addition or subtraction. That's the key about terms, is that they're separated by addition and subtraction. I'm going to give you an expression. Tell me, what are the terms? Nine xy is a term. 2 times 4x plus 7 is a term. And minus 15 is a term. Those three things are separated by addition and subtraction, therefore they are the terms. 4x plus 7, or 2 times 4x plus 7 is all one term because the parentheses lump the 4x plus 7 together and multiply it by 2. Therefore that's all one cluster or all one term. So yeah, absolutely. 9xy, 2 times 4x plus 7, and the negative 15, those are all terms. Okay, so what makes up a term? Factors. Terms can get broken up into factors. And factors are the parts of a term that get multiplied together. So, there you've got an expression, 7x plus 9xy. The 9, the x, the y, the 7 for that matter, those are all, in the second term only, 9x and y are your factors. They are the factors that make up the second term. The factors that make up the first term are 7 and x. Now that's basically the bottom piece. You can't break up a factor anymore except into smaller factors. You could break 9 up into 3 times 3, but that's getting a little carried away. But there are certain kind of factors that have got a special name. Coefficients. Coefficient is basically a numerical factor that's in front of a variable in some term. So for example, If we have 9x cubed plus 7x, the 9 is the coefficient on x cubed, and 7 is the coefficient on x. If there was a number added on to the end of that, we would simply call it a constant instead of a coefficient. Another one. Equations. Well, we kind of already touched on this. An equation is formed if you have two expressions that are said to be equal. Example of an equation that's kind of silly. Everybody knows what an equation is. That's the one that everybody knows. There's an example of an equation. Two expressions, and we're claiming that they're equal. There's not much to an equation that you don't already know. Okay, so that's our foundation. Now we're going to look at a couple of specific kind of expressions that we're going to deal with a little bit more often than other types of expressions. Well, anyway, a polynomial is basically an expression where you've got a bunch of terms, and typically there's a variable raised to some power. Now that power has to be a certain kind of power in order to be a polynomial. That is, the powers must all be non-negative integers. So, for example, negative 9.2x to the fourth plus 2.7x to the fifth minus 4x squared plus x minus 6 has to meet the criteria of a bunch of variables raised to powers with coefficients, and the powers cannot be negative and they must be integers. If you have a negative exponent, not a polynomial. No deal. That is a polynomial because all the powers are integers. Incidentally, if those powers were decimals, like 4.5 power or x to the 3/2 power, it's not a polynomial. We just call it then a plain old expression. Or a multinomial, which is a very rarely used term. Well, a little bit more about polynomials. The degree of a polynomial. The degree of a polynomial, every polynomial has some degree, and that degree is the highest power that occurs on any of the terms. So as you scan a polynomial, you spot the highest exponent you see, and that is the degree of your polynomial. For example, that's the polynomial I just showed you, negative 9.2x to the fourth plus 2.7x to the fifth minus 4x squared plus x minus 6. Fifth degree polynomial. Those are the terms you need to know. Those are all listed in your textbook, listed on the study pages on that little calendar. Now we're going to wrap this up by doing some very simple algebra here. Polynomials can be combined by simply distributing if necessary and then adding like terms. And you have undoubtedly done this somewhere along lines before. We're going to do a couple of very short examples. Here's an example. We want to simplify 1.73x plus 12.97y minus 2.52x squared plus 9.8x minus x squared. We want to simplify that. Now, I haven't got it written out, but when you rewrite a polynomial, or when you combine like terms, anybody know the general rule that you typically want to follow? Does the order of the terms matter when we combine? It doesn't. But kind of like in writing, there's certain rules that you want to follow, like capitalizing names. Even if you don't capitalize it, you still know what it means, or you can read it. It's just the proper way to do it. You usually want to write the highest terms, or the terms with the highest order or degree, first. So let's start out with the x squared terms. We've got negative 2.52x squared minus x squared. How many x squareds have we got? Negative 3.52x squared. Anytime you don't see a coefficient like on that x squared, there's no coefficient there, you can always assume that it's 1. So we got negative 3.52x squared. Now let's go on and take care of the x terms. 1.73x plus 9.98x 11.53x. In our y terms, we've got 12.97y. There are no other y terms, so we can just leave that on the end, plus 12.97y. And that's it. We've combined the like terms. We've simplified it. The thing to distinguish is that even though the variable is x here, you can't add these because they are of different order, and so they can't be combined. Those are unlike terms. That's the bread and butter that you need to know. Now, as it sits right now, the way that this expression sits right now, how many terms are there? Just as it's written. Exactly, there's 2. The parentheses lump smaller terms together, and so there's 2 main terms there. Well, we're going to get rid of the parentheses, so we're going to have to distribute that negative sign. That's the only thing that we want to be careful of here. So the first set of parentheses, do they really do anything? We can get rid of them. So we have 8.52a. Whoops, lowercase a, my mistake. Plus 2.47c. Now we need to distribute that negative sign across everything inside. It's like multiplying by -1. So we have minus 9.5c, minus 1.7a, and negative negative becomes plus 2b when that negative sign gets distributed. Okay? Everybody agree with the signs on those last 3 terms? Okay? And well, now we can combine it just like we did the previous one. If we do that, our a terms, you get 8.52 minus 1.7a. We tend to typically, regarding sigdigs, usually when doing algebra, you usually treat coefficients as exact values. And so you can pretty safely assume that when we're doing algebra, which is the next couple of weeks here, we're just going to work on algebra, linear equations, different types of functions. We're going to assume that all the coefficients are exact values. So we end up with 6.82a. B's, we've only got the 2 b's, so plus 2b. And finally, 2.47c minus 9.5c leaves us with negative 7.03c. And we've got that one simplified. Distribute, combine like terms. Okay. All right, well, first of all, we'll distribute that 4 across the first set of parentheses. 4 times 2 plus 3x, 9.2x. 4 times 9.3, 37.2. All right? Now, here's where a common mistake is made. Be careful of this. Is that 6, is that negative sign locked to this 6 or not? It is. So when we multiply, when we distribute, we're going to take negative 6 times each one of these 3 coefficients. So when we take negative 6 times 3.7, we end up with negative 22.2. Take negative 6 times negative 2.6x. You end up with plus 15.6x. And negative 6 times positive 1.1y leaves you with negative 6.6y. Now we've cleared all the parentheses, we've done our distributing, we can just combine the like terms. So we'll start out with the x's. 9.2x plus 15.6x leaves us with 24.8x. Y's. There's only one. Minus 6.6y. And finally, on the end, we got 37.2 minus 22.2. Does that look better? Good, thanks. What's that? Yeah, that's right. Can fix that. Never happened.